The AME is the future of manufacturing and engineering. By uniting academia, industry and cutting-edge research, we're not only advancing manufacturing, our award-winning faculty on the factory floor approach is elevating education to create a centre of engineering excellence. Our industry-driven research guarantees partners have access to the latest manufacturing equipment and processes, exceptional knowledge, a pool of talented graduates, state-of-the-art testing infrastructure, and so much more. Join us in this innovative journey as we lead the way in manufacturing and engineering, transforming the industry and creating better futures.
Morning, everybody. Wow, this is a nice room. Thank you all for coming and welcome to the AME. For those who don't know us, it's the Institute for Advanced Manufacturing and Engineering. It's great to see so many faces here, faces that have been involved in the journey over the last 10 years. And it's also great today to have something unique, which is the metaverse. What you can see here on the screen on the left is a virtual representation of this room and the entire building, where we have people from around the globe tuning in to our events today and participating and experiencing the AME. So if you are online in the metaverse, you're probably hearing me now, so I'm told. So you are also welcome to put questions on the chat and interact with the guests throughout the day. So we will start by just covering some ground rules and some housekeeping. So there is no fire alarms planned today. Only for today, we will have no machines operating on site, so you'll be safe to go around without safety shoes and high-vis vest. If there is a fire alarm going, it is a serious fire, there are fire exits behind me and behind you through the double doors out into the car park. One of our fire marshals will guide you through. Okay, so we have a packed day, a lot of speakers here. What we try to do today is, rather than telling you the story, we invited some of our partners, collaborators, and students to actually, try to bring that story to life. Where we have developed projects with products and technologies that went into the market, we'll be exploring some of those results with you today and telling that story through the voice of our collaborators, partners, and students. So we'll just start by inviting Carl Perrin here. Carl was the original AME director who came in to set up the site. Carl will talk a little bit about the background to the AME and why it was set up to begin with.
Yeah, thank you very much, Marcus. So again, welcome to everyone here in the room and virtually on the metaverse. So it makes me really, really proud to be here relaunching the AME. It's virtually 8 years to the day, I think, since we originally launched. I suppose what I want to do really is give a little bit of context to why we're here now and why we are relaunching, because we have kind of reinvented the AME and what it's all about. But if we step back to maybe 10 years ago when the idea was originally tabled for doing something like this, it really came down to skills and support for the manufacturing sector and the fact that businesses, and I was working in a business at the time, I was working in Rolls-Royce, we were struggling to access the right skills to be able to drive productivity, drive new technology forward. And this was a common theme. It was being talked about all the time through the manufacturing sector. And what happened here was a business and the university got together and decided to do something about it. Work together, understand what the problem was, and create a solution by working together to give an integrated education program, developing technology together, and then commercializing that technology. And it was those three core principles of education and skills, innovating and developing new technology as the world was changing, and then doing something with it, taking it forward, commercializing that technology. And so the proposal was put together to create what is the faculty on the factory floor. And those 5 words are so powerful and still are in describing how we do things, because instead of building another university building on the campus away from the business, physically being here with the business creates so many more opportunities in how we integrate to one another. So we set out with a completely joined up approach in terms of our strategies and the way we worked with people from the university, our academics, researchers, and the students based here in the same room working alongside the engineers and other staff from Unipart. So when people talked about Valley of Death, when we commercialised those technologies and moved it up the TRL level, it didn't exist for us because there was a seamless handover. And you're going to see several examples today of where that's really worked and come to life, driven productivity and growth in the sector. So we set out on a journey with what the challenges were back then. I'll talk a little bit about the technology roadmap we did back then in terms of what we should invest in, where the challenges are. And clearly, as you'd expect, over the last 10 years, things have changed a lot. The challenges are different. Skills is still on the agenda as important, but the things that are being talked about now and the skills that are needed are really quite different to what we were talking about 10 years ago. And that's what's informed us of making new investments, expanding here to create bigger reach in what we're doing, address wider sectors, and really move it forward to make it relevant for the future. So I'm excited about today. I really want to engage with as many people as possible. There's lots of people here who I don't know already, so for me that creates a lot of opportunity for the future, and looking forward to a great day. So thank you again for coming.
Thanks, Carl. Great. So just before I hand over, thank you, Ralph. So just before I hand over to John Latham, our Vice Chancellor, to say a few words about why Coventry University think the AME was important 10 years ago and why the university think it's still important and why he invested £5 million on this expansion, I just wanted to cover some of the agenda today. So has been involved in the AME from the conception, is at the core of why the AME is here today. Carol will give her view. We'll then have a message from Andy Street. Unfortunately, he's not able to be here with us today, but he sent a 2-minute video, which we'll play. Andy's talking about the importance of the AME for the engineering community in the West Midlands. We then have local authority, represented by Councillor Jim O'Boyle here, who will say a few words as well. And then from there, we'll go into this journey of the AME. What have we done in the last 10 years in the words of our partners and collaborators? And we'll have an opportunity then in the afternoon to go for a tour, and you'll see all the equipment that we got, and you'll be able to interact with some of our academics and engineers on site. And hopefully we'll end with lunch and networking upstairs. So you're all welcome to stay for as long as you like in the afternoon. Ask any questions that you have and interact with people, both here physically, but also in the metaverse. Okay, with that, we'll just play a short video.
The AME is the future of manufacturing and engineering. By uniting academia, industry and cutting-edge research, we're not only advancing manufacturing, our award-winning faculty on the factory floor approach is elevating education to create a centre of engineering excellence. Our industry-driven research guarantees partners have access to the latest manufacturing equipment and processes, exceptional knowledge, a pool of talented graduates, state-of-the-art testing infrastructure, and so much more. Join us in this innovative journey as we lead the way in manufacturing and engineering, transforming the industry and creating better futures.
Okay, thank you. So that's a preview of what is to come in the faculty on the building tour in a minute. So I think my slides are in a different order. I'll just skip to introduce John. Carl, if you...
Okay, great. Thank you very much. Do I have some facts?
Yes, you do.
Go on then, give me the facts.
I'll give you... Oh, there we go.
There you go.
I can keep
That's
these
the
if you want.
important bit, the
Perfect.
So, unaccustomed as I am to only having 5 minutes, I'll try and make sure that I fit within 5 minutes. But really, the first thing for me is to say, friends and collaborators and partners and stakeholders, and particularly Carol here today, thank you for coming along really to recognise what has been an immensely successful journey for the collaboration between Unipart and the university, creating what has been seen and still is seen as a very innovative approach to the delivery of education, research, collaboration activity. And there's no doubt about that. And the stats that we've got up here speak for themselves in terms of what we've managed to invest, but actually the outcomes and the outputs that have been generated from what in some ways is quite a small investment, but in other ways is a large investment. And that balance between the outputs that's been generated and the amount of investment that was needed to go in, that collaboration across industry and higher education and government, because don't forget there's money in here from the LEP, there's money in here from central government, there's money in here from a lot of research agencies have been supporting us over the years. This has all been a truly amazing, innovative success story for us as a university, but I think actually both for the sub-region, the region, and the UK. I travel the world a lot, many people know that, and many places I go talk about this. They want to know how we did it, what does it do, how does it work, how could they potentially duplicate some of the activities that's going on. But the difficulty is not building what you're seeing today, it's building the mindset of that collaboration and willingness to engage, to break down the barriers. Coventry University is really proud that what we do is we tend to go out from outside our own boundaries and work with partners. We have a big collaborations around the world. We have big collaborations here in the UK. What we're about is making sure that we put together a solution that will make a difference. In all that we do, we are very partner focused. That is one of our success stories. That's one of the things that we've managed to do on this journey. And this is a true reflection of how that works. What you don't see here, of course, because these are hard facts, and hard facts are always good, is the journey that's happened over that 10 years since the first idea, the 8 years, the now second stage relaunch that we've got today, and actually the quickening of the pace, the acceleration of the activity, but actually the journey that is continuing. A lot of the technology you see here today is around looking at sustainability, is around the digital future. We've got the metaverse, and it's good to see colleagues coming and joining us today, but actually this is the future for all of us in all areas and in all sectors. But what we're seeing here through this collaboration is the take-up of those technologies and the reinvention of those technologies, continual process through those 8 years and into the future. And that's something which is going to be really key for us. We have been recognised many times. The Queen's Anniversary Prize, actually meeting up with King Charles and talking and discussing what that means, is a great accolade. But actually the real accolade is the outputs that are being generated here. The graduates that become employed, that go on, that actually have an impact in industry, the amount of research that we do, the IP which is generated, the interactions that we talk about, all of which universities are here to do, but this is a really good example of doing it well and actually generating outcomes, generating outputs that make a difference. And we can see, because actually not just here, we go back to the university campus, there are other things that we're now doing. Some of that is based on the fact that we've been so successful here. All of the stuff we're doing around the EV skills, the EV skills center that we've got, developing skills that will generate the engineers of the future around electric vehicle technologies. A lot of that is recognition of what we've been doing here. Actually, if you look at the NCAT stuff that we're doing around mobility and the development of new technologies for access into transport, it's all recognition for the university that we are a centre of excellence, and that centre of excellence is growing in terms of future transport and future technology. So today, what you're seeing and what we're relaunching today is a celebration of what makes Coventry different, but what makes the journey that we started 10 years ago a truly successful journey that many are trying to emulate. So I'll stop there because I'm sure I'll have had my 5 minutes. And I think I'm handing over to Carol now, actually, in terms of where it is, to come and talk. But I'm really pleased that we're here today, and I'm really pleased that we're here with Carol as our sort of initiator. Thank you.
Okay, good morning, everybody. Just before I start talking about the benefits, which is not so difficult, I just wanted to personally thank John. One of the reasons that we're stood here today is because of the huge effort personal effort on the part of John, but the organisation that went around bringing together Coventry University and Unipart those 8 years ago was phenomenal. The two worlds are very different. Academia and industry is different. We had to break some rules. I think it's okay to say that. Treasury didn't like the idea too much, and so we had to do a lot of persuasion to explain why this is of huge benefit. We won on that day, and I'm really delighted today to be stood here talking about the future. So as I mentioned, it isn't so difficult to talk about the benefits. So in the first instance, skills and industry-ready graduates. If you're an undergraduate, an engineering undergraduate, as I was quite a few years ago, and you learn in a facility like this, and you do all of your projects in a real manufacturing site, and from day one, you're in effect talking to industrial engineers and understanding the world of work, then you are undoubtedly going to be a better engineer and better able to contribute to the world of work from day one. And we've gone on to prove with the 400 students that indeed that is the case. And of course for the university, they have an exciting degree course to offer. For us, it's the skills that we need to generate new business in the future. In the second instance, it's about research and development. So we have access, unashamedly, as an industrial partner, we would not have access to the world that we see without our partner, Coventry University. We wouldn't be able to understand the technology roadmaps that drive the future. And it's that partnership, that access, and of course by working together, we attract funding from our partners, not least of all Coventry City Council, the West Midlands, and of course the APC that are here today as well. All of that ecosystem, when it comes together and works effectively and efficiently, it drives growth in our economy. And finally, the business growth. Once again, university needs the research and the industrially relevant research, but we as industry, with customers, with our supply chain, with the SMEs that we interact with every day, we need business contracts and new growth. Since we formed the Institute, Unipart Manufacturing has secured at least £250 million worth of additional business. Now, obviously, securing new business of that magnitude is complex. It involves lots of things. But I have no doubt whatsoever that the AME and the benefits that I've been talking about, skills, R&D, business growth, all of that, when it comes together, has made a very significant contribution to that business growth. And that growth contributes here to Unipart, clearly, but to the West Midlands and to the United Kingdom and inevitably globally. So looking forward, which is also important, the transition that we will make from ICE to electrification means that that interaction, that blending together of the two organisations is so essential as we move forward. The AME really has grown up in a period of change. So technological change, COVID, all of it has made us the fit organisation we are today. Unipart itself has changed. So we used to talk about manufacturing. Today we talk about supply chain solutions. As a different business that's been led by Darren Lee, our CEO, and I'm really delighted that he's here to celebrate the contribution that manufacturing can make to that supply chain, but also to talk to John about the future and about how, instead of seeing individual parts of that supply chain, the real power comes from us all working together, as John spoke about so eloquently. So I am delighted to be here today. Thank you to John and Coventry University for the contribution you have made to Unipart, to the West Midlands and to the UK. It's been a delight working together, and I know the future is really strong. Thank you.
Thank you, Carol. Just to follow up then, we have a short video from Andy Street, who is the mayor of the West Midlands Combined Authority. Hopefully it will play on click.
Hi there, Andy Street, Mayor of the West Midlands here, and it's my pleasure to say a few words for the relaunch of Coventry University's Institute of Advanced Manufacturing and Engineering. This is an institute that's been going for 10 years now, and it's already done a brilliant job creating lots of economic activity. We think about £350 million worth of economic activity, 200 graduates already going through it. But as you all know, today is about the relaunch. I'm really sorry I cannot be with you today, but I wanted just to stress how important I think this is for the future of the West Midlands economy. We know we're at the centre of engineering, centred particularly the automotive industry, and that industry going through transformation. So what the university and the Coventry and Warwickshire LEP have done to invest £6 million in new state-of-the-art facilities, bigger facilities, able to take more people, really does put us at the cutting edge of new engineering innovation and productivity advances in these critical sectors. So I should say a big thank you to both the university and the LEP for what they have done, and of course wish everybody who is going to benefit from it, whether it be individuals or companies or indeed our region as a whole, all the very best of fortune for it. Thanks to everyone for this new development today.
Okay, so that's Andy. Thank you. And with that, it's my pleasure to invite local councillor Jim O'Boyle to come up to the stage and represent the local authority who invested also £1 million on the AME expansion. So Jim, I will hand over the mic to you.
Thank you. I'm not sure I'm going to do this. I need 3 hands, to be honest. You haven't got a mic stand up here?
I can hold that or the mic for you.
Right. Perhaps get me a chair, because I'm not going to be able to do this, really. So, one of the most advanced manufacturing and educational facilities in the city, and they haven't got a mic stand. Sorry, I couldn't help having a dig. I used to work in a car factory. I've got to say, it didn't look anything like this at all. So look, good morning, everybody. I'm delighted to be here today. It's a real privilege to be invited to speak and also to join you all in the relaunch of the Institute of Advanced Manufacturing and Engineering. The journey to this point is testament to the team's resilience, vision and commitment to progress. And of course, nothing is possible without strong partnership working, in this case, the community and a number of industrial partners. For our local community in Coventry, the AME isn't just an educational institution, it's a real beacon of hope and opportunity. It signifies growth, new job prospects, and a chance for our city's young people to get real hands-on, state-of-the-art training right here in the heart of Coventry. For our industrial partners, it offers a unique collaboration, has been said, a faculty on the factory floor, ensuring a steady stream of skilled people ready to take on real-world jobs and challenges. When the local enterprise partnership in Coventry and Warwickshire decided to invest in the AME, it was because it believed in the potential of Coventry, in the ambition of Unipart Manufacturing and of Coventry University, and of course, in the talent of our local community. In doing so, it was investing in the future of manufacturing in the United Kingdom, and more directly, in the prosperity of our city and the wider region. During the lifetime of Coventry and Warwickshire Local Enterprise Partnership, over £300 million of taxpayers' money in funding was secured for infrastructure projects across Coventry and Warwickshire. This included over £130 million as part of the region's local growth fund allocation. The range and scale of projects built on our regional strengths, and in 2018 Coventry University was awarded £1 million towards the AME expansion project. This helped to create and secure jobs and led to engagement with multiple businesses. In many ways, it has helped us to bring us to the point that you are today. The portfolio of projects supported by CWLEP across the region helped to create over 4,400 jobs and apprenticeships, built 5,000 new homes and delivered 6,000 square metres of new space for learners to develop and to innovate. The impact and outcomes of Coventry Warwickshire LEP capital funding programmes continues to be felt today, and there aren't many better examples than this facility right here. Since its inception, the AME has achieved commendable milestones, from pioneering research in lightweighting of automotive components to battery technologies and processes to support electric vehicle manufacturing. The AME is synonymous with innovation. Connecting students directly with industry has not only benefited their personal growth, but has bridged a vital gap between theory and practice and has enabled our local industry to grow. But this is just the beginning. I'm sure the AME will become a global reference point for manufacturing and engineering education. We see it fostering even deeper ties with local industries, leading to further investment, job creation, and solidifying Coventry's reputation as an innovation hub. And of course, as we steer towards a greener, more sustainable future, we hope that this facility to be at the forefront, leading research and providing solutions for a more sustainable industrial landscape. So as we stand here to mark the relaunch, let us remember that this is not just about reopening doors to facility, it's about reigniting dreams, ambitions, and a shared vision for a prosperous Coventry. It's worth saying that Coventry mirrors very much some of the innovation and ambition that AME and Coventry University has got. When we look to the future of advanced manufacturing, we look to the future of the jobs of the future in Coventry in the United Kingdom. Coventry's got the most electric vehicle charge points anywhere in the country outside of London. We are future-proofing our city for the expansion of the electrification of our country and of our industry. Coventry is the location for UK Battery Industrialisation Centre that is developing the batteries that will drive both transport and energy storage in the future. And of course, Coventry is at the forefront of developing Coventry Very Light Rail, which is a fantastic new transport scheme that will completely revolutionise very light rail across this country and indeed across the country. There is a lot to be excited about Coventry and a lot to be excited about why we're here today. So I'm pleased to be part of this pivotal moment for the Institute of Advanced Manufacturing and Engineering, and I look forward very much to seeing ongoing progress and innovation as I've described right here in Coventry. Thank you very much.
Thank you very much, Jim. Now we heard from our Vice-Chancellor, we heard from Caro and Unipart, we heard from Andy and Jim. So we have a good mix in there of stakeholders. We just missed one very important set of stakeholders, which is our students. So we have a short video here from our AME former students for you.
The AME for me is the place I study, and it's brilliant because I get the exposure I wouldn't get anywhere else. You've got brilliant companies who work right downstairs, so you meet people with real life experience, you get to talk to them day in, day out.
The AME has an abundance of subject matter experts, which I feel like you can ask for advice and how to use certain pieces of equipment that you just wouldn't get starting out in industry.
The main benefit of the AME was my readiness for work, if you like. So as soon as I secured my role at the end of my degree, I hit the ground running and I was straight into big projects. I didn't really have to do any training time.
Working alongside people who didn't come to a facility like the AME, oftentimes there can be barriers to starting work because they want to get read up on things. And I feel like the AME really prepares you to just get stuck in, get hands-on and kind of learn by doing.
Once we had our lectures during the week, we'd actually come to the AME and apply the learning we had there. So for example, if we had a metrology lecture on the Tuesday, we'd come to the AME on the Wednesday and apply what we learned on the real machines and actually do some trials and some experiments.
It's beneficial because we already know what industry is going to be like then. We know what to do, what it's going to involve.
The course that I did really pulls from industry into education, whereas I think other courses can try and push from education into industry. And I think that meant that the course that I did was much more tailored for the industries and scenarios that I've been in since graduating.
So not only did I learn so much from the AME, I also had 2 summer placements, one at Unipart and one at Subaru of Indiana in America. So that was all organised through the AME, and that was a really good experience because it was obviously such a large OEM. So I learned a lot more in a highly automated area, and I worked in the body shop for manufacturing engineering.
AME definitely has given other cohorts before me, others coming after me, a leg up into industry, which, yeah, you wouldn't get in many other places.
Studying at the AME made me feel really confident moving into the roles I have.
And I think that's one of the main things I took from the AME. So when I first started my degree, I was super shy, couldn't really speak to anyone, but it really helped build my confidence.
The AME is somewhere that's going to help me prepare for my future.
Can we have a round of applause for our students? Thank you. So as you walk today, you probably noticed that the T-shirt on some of the students, they're former students. They wear a Hyperbat T-shirt, so they are working next door in the Unipart and Williams factory, making battery packs. You'll be seeing them as you walk around today on the tour. Also, when you go upstairs for lunch and for the coffee, you see the classrooms where we have lectures actually going on today upstairs. So feel free to stop any students and talk to them if you wish so. And ask what their experience is like and what do they think of the AME. And hopefully you get a very cohesive message. They all like it, they all enjoy it, and they all see the benefit of being in the faculty on the factory floor. So with that, I think what we want to provide now is a more detailed overview of how the AME model works. And no better way to do that than to talk through a real project where skills were developed, where people were trained, where technologies were developed, where new products were sold. So I will do a little bit of a double act with Carl again, because Carl will tell you the beginning of the story, I'll tell you the tail end of the story, and then I will re-invite Carol to join us on stage and then tell how the technology and the skills are enabling Hyperbat to sell batteries to the most exciting electric vehicles in the UK. So Carl, if you can join me. Sure, in the middle, so I don't.
So, you've heard a lot about Hyperbat today, and you'll learn even more about it when you go out around the facility and see what it is. But for me, it probably embodies the best success we've had so far of this partnership for many, many reasons, and it covers so many of the things that we set out to do. But if I wind back a little bit, we've talked a lot about the amazing things we do and why we're special, but we haven't told you how we do it and how we go about these things. And one of the important things is the people we put together when we started this partnership and trying to bridge that language between industry and academia, because they are different, as Carol said before, and it would be wrong for one to assume they know all of the answers. So, for example, a university setting out to try and fix the manufacturing skills problem would get it wrong because they don't understand what the businesses really need. Similarly, the technology that needs to be developed, what the challenges are out there, the universities in setting out to do low technology readiness level research need to understand what the businesses are looking to take forward and commercialise, what the challenges are there. So we set out right at the very beginning around developing some technology roadmaps. And some of those roadmaps were really quite short-term because we got some short-term KPIs to hit, some deliverables back to the funders, but we also put some long-term targets on those technology roadmaps. And we co-developed them, not actually just between Unipart and the university. We had the funders involved. We looked at some of the OEMs and other customers, across the commodity range that Unipart was working on at the time, back 10 years ago, we looked at where we might be in a year, 2 year, 5, 10 years' time, and tried to map forward what we needed to do for the business to succeed and grow. And it ranged from introducing new products to driving productivity improvements through new technology as that would come along, and adopt new enablers beyond what technology was around us at the time. But it also allowed us to build the curriculum for the education programs for the students, and crucially, not just that, but build some ongoing upskilling programs for people in the business as these new technologies would be incorporated in the organisation. And Hyperbat's a perfect example of that, because when we came along and developed those initial roadmaps around exhaust pipes, for example, or fuel rails, we were looking at things like lightweighting, but still sticking with internal combustion engines. So we did some really good projects around, for example, lightweighting an exhaust that Unipart were manufacturing for Aston Martin at the time. That went into production. It was quite a quick project. We went about it in a completely different way to what we would have done in the past, where instead of prototyping in the workshop, which is actually what's been decommissioned and recommissioned as the new AME, we did that design work in the virtual world. It was the first digital twin project we had, and Marcus will talk a lot more about digital twins because that's a technology we've moved forward in many different ways to help organisations develop and introduce their new technology and new business models. So we worked on things like lightweighting. We developed, based on those technology roadmaps, our investment plan from the initial investment. So we had what we called anchor technologies. There were 6 anchor technologies around welding and joining, metrology, simulation, and they were right at the time. But we always knew that those technologies wouldn't last a long time as we were continuing to innovate, the university developing new technology and doing more fundamental research, and those technologies moved into production. The opportunity for research would reduce. We would deliver impact from commercializing those technologies, but we needed to keep that eye on the long term, understand what technology was coming along, and keep those roadmaps live with lots of different inputs from all of the key players in there. And we've done that. And that's what's really led us on to where we are today, with the reinvestment in digital technologies, focus on sustainability, what the big challenges are for the manufacturing sector now. And we shouldn't be surprised that actually businesses are saying they're the skills that they're looking for now. We want people who understand digital technologies. That's holding back the level of adoption of digital technologies in organisations and maximising the opportunity from that. So introducing those into the curriculum through this extremely rich environment that we have, where a business is developing technologies, there's production systems live on site for the students to learn, is what makes this so special in what we do. So Hyperbat took some initial fundamental research that was going on around 10 years ago, some work with the MTC that Marcus was actually involved with back then when he was a Unipart employee, saw an opportunity that electrification was going to come, but it wasn't coming yet. And gradually over time, we invested in the technology to develop battery packs. We invested in laser welding. That was a new investment, probably about 4 years into the original AME. The APC supported the Hyperbat project, which moved on to Hyperchain, developing the supply chain. And then the formation of the business, the joint venture with Williams, now sees Unipart producing batteries for Lotus on site, and a massive growth area and future in electric transportation. So you can see how skills comes together. The students that graduate having experience and learning with the business, developing batteries, and then moving into the organisation once they graduate. Really embodies everything that we set out to do in those 3 fundamental things of developing skills and capability, doing research, and commercialisation. And it's that really creates the win-win for Unipart or any other business that works with us and the university. So that's a little bit of an insight into how we work and how we're strategic together, using Hyperbat as an example.
Thanks, Carl. Yeah, it's amazing to remember, for those who are involved on the EV Light project back in 2012, 2013, it was one of the first battery projects in the UK. It was with the MTC. At the time, I was the technical lead from a Unipart point of view, engaged on that project. And we come a long way. And it's staggering. We were doing the numbers a few weeks ago. £18 million in total of investment in this building, in equipment, which is amazing. But even more staggering is the amount of projects that we've been involved and the total value of those projects, which is over £110 million in projects, which resulted in almost £500 million of benefits. So it's great. And throughout that journey, as Carl said, we work with Unipart, but also with the wider supply chain. And there were some key insights which really we want to focus on. And those are non-obvious areas of skill development and experience that we provide to our students here in the AME. So when we look across the range of projects that we had, there are 3 common drivers that affected all of our collaborators. And those are listed on the left here. So they were either looking for lean manufacturing opportunities, so making products more efficient or cheaper. So that is producing incremental innovation within existing products and product lines. The number 2 is around Industry 4, and that's a general term that we are using here to represent digitalization. So very often our partners are looking at automating, digitalizing, changing the way they manage data and information in their business. And both 1 and 2 lead to also to number 3, which is around sustainability. Sustainability from a product development point of view, selecting materials that are sustainable, but also selecting manufacturing processes and production methods that are more sustainable. Now, those 3 drivers affect directly the economic, social, and environmental output there. And you can teach theory in the classroom across all those 3 areas, but what you cannot teach without the model that we have in the AME is what we got at the bottom there, is how do you become more innovative as an engineer? How do you learn to be a systems engineer that can develop sustainable, connected, smarter, and faster technologies in a group of collaborators? And we can offer that here in this unique environment that we have. And what Carol will describe in a moment in terms of the journey from HyperBat, which was a project funded by the Advanced Propulsion Center between Unipart Manufacturing, Williams Advanced Engineering, Aston Martin. I'll probably forget some of the partners, but Coventry University was one of them as well. So we have also learned in terms of how we set up the AME and how we support our collaborators that there are 3 very well documented reasons why innovation fails, not only manufacturing but in general. And those are related to how you design your innovation strategy. And that's what Carl was saying about the roadmaps and how important those are. If we know what you need to do today, if we know what you need to do in 5 years and in 10 years, we can make strategic decisions as to the skill development that we make, but also what equipment do we procure and how do we invest some of our research equipment and some of our capabilities. So those 3 aspects in there: innovation strategy, knowing what you're doing and how to do it; the innovation system, who you need to collaborate with, where do you get the knowledge and the technology; and then finally, and most importantly in my view, the innovation culture. How do you build a relationship and a network with collaborators that actually trust each other? And this relationship here in the AME is very much based on trust, on that continually working together for mutual benefit of the partners. So really, what we provide here upstairs to our students and through CPD, continued professional development, to our partners is more than just theory, is more than just engineering teaching in a lecture room. We provide them with an environment where they can learn about this innovation strategy, innovation systems, and innovation culture. That will make them better engineers that will help our partners to drive change and implement technology in their business. My last slide before I hand over to Carol is a little bit of a busy slide, but is a model that we use here very often in the AME. What that slide represents is a business in the middle being affected by a lot of change. And that's the main constant of life that everybody will relate to. We have seen in the last 10 years how far technology manufacturing has come and how the world completely turned upside down in terms of our supply chains and the drives from more efficient engines to now electric vehicles that are carbon neutral or net zero, if that's possible to achieve. What we try to do here is put your business at the center. Whether you are a startup company, you'll hear from Ravi later talking about Global Nano Network, or whether you are a very large company, very well established like Unipart Group, and you'll hear from Carol and Andy later. What we try to do is to understand what is affecting you, what is disrupting your business from a skills, from a technology, and from an innovation point of view. And what we try to do across the university, not only with the teaching and skills, but also with enterprise and innovation, and you'll hear from Paul Noon later, but also with the research investment, and you'll hear from Richard Ashwood later, is to try to align our efforts, our investment, our skills, and our resources to help you. And if we do that well, we deliver very good value for money, for our students, for our collaborators, and for the taxpayers. That's my last slide, and I will have the pleasure to ask Carol to come back in and talk a little bit about her perspective of Hyperbat.
Thank you very much. Oops, wrong way.
One more.
Going to get there eventually. There we are. So this is where it gets real. I'm going to talk to you about the real world in which the AME operates with industry. It's actually critically important when you're going through a transition, and let's face it, the move from the internal combustion engine to electrification and other low forms of propulsion. It is huge, it is massive what has happened to us, and therefore it's critically important that we as industry have a clear strategy. In the first instance, we need to maintain our ICE business. Guess what? Because it funds what we're doing today. So the AME is very integrated into how we solve customers' problems today, and that still does involve the internal combustion engine. And it's important we continue to do that. Andy's going to talk a little bit more about that. At the other extreme, we have our new strategy that's been developed with Unipart and Darren, which is really thinking through how we use this facility and 35 years of experience as a first-tier manufacturer of safety-critical components, how we use that actually to support growth and enter new sectors. So once again, scaling new technology, understanding those technology roadmaps that Carl and Marcus have talked about is key to the way the AME supports our growth. But what I want to concentrate today is this middle section here, which is our growth of Hyperbat. Hyperbat began, as Carl and Marcus have explained, as a research project here in this building. So this is where it started. And obviously today, it's a new business growing massively. Okay, so I'll try not to keep turning around. So just a reference to the transition. So everything has changed. It is impossible for me as an industrial partner to know what I need to know to enter a new sector, to grow new technology. That's the purpose of the AME. So whether it's working with new partners, whether it's developing skills, whether it's new infrastructure. I mentioned safety critical components. A battery is a fairly dangerous thing, and therefore making sure that a factory can handle that is new for us. And as a limited team, we've had to adopt those changes and work with those changes. And so the people in this room and back in the factory and in the AME all are playing their part in that. But I did want to get into just a tiny bit of detail as to 4 key areas where I think the AME has made a massive difference. So in the first instance, welding technology, joining technologies is absolutely key to manufacturing batteries or assembling batteries. And so being able to develop that capability to actually weld materials that don't want to be welded together, that's not a new phenomenon. What is new is doing that at the kind of speeds and cycle times that we need to make every one of those 100,000 welds work. Every single one of them has to be right. We cannot pass a fault forward, and therefore it's that technology linked with our manufacturing capability that's been developed over that time that has created the new business Hyperbat. Supply chain, we've mentioned. Part of the relaunch of the AME is to understand the UK supply chain and to support Unipart and its customers in developing new supply chains. A battery is a complex component. We haven't simply been able to source the parts that we need. It's underdeveloped here in the UK, and actually when you look globally, much of it commoditized. It's impossible to get a harness that we want today and actually in 2 or 3 weeks' time get a different harness. So it's not just about the battery assembly, it's about understanding how we create that new business and the supply chain around that. And again, the AME has been instrumental in helping us establish a new portal so that we can talk in a very transparent way with our supply chain, so that we actually genuinely reduce costs to be competitive, rather than that perhaps traditional automotive approach of just beating our supply chain up. So there's lots of new approaches that we're using to develop our new business. And also, of course, not only do we need transparency with our suppliers, we actually need transparency of the whole value chain, the whole supply chain. We set out to have an entirely paperless smart factory. So right at the product life cycle management system, through the ERP, through our manufacturing execution system, through our quality management system, right down to where we collect the data on the shop floor. All of that is fully integrated. And that means that we're flexible with whatever technology arrives. I was talking to John Latham earlier about in 5 years, the technology will change again. And therefore, as manufacturers, we need to be able to adapt that quickly. You know, the last 35 years, we've been making parts for the internal combustion engine. In the next 5 years, we'll have a new propulsion technology, guaranteed. And therefore, we need this facility. We need to be working together to make everything happen. Hyperbat, you'll see it a little bit later, has doubled over the last 2 or 3 years. It's about to double again. Right at the heart of Hyperbat is its people, and the ability to bring in new talent, new capability, new graduates, but also to develop and support our current workforce is absolutely key to the transition that we're making. And once again, the AME is critical to our success. So I am absolutely delighted to be stood here today. I'm not sure. I think that might be a clue, folks. So thank you very much. I was expecting a big logo there, a big flashing logo to tell us that instrumental to all of this is the AME. So thank you very much for everybody that's been involved. And now let's enjoy some coffee. Thank you. Does make a big difference there.
No, it was okay. It was good. I think they were just telling us to do. Okay, thanks, Carol. So we are a little bit ahead of schedule. I would like to, just before we go for coffee, if anyone in the audience has any questions that you would like to ask our Vice-Chancellor, Carol, Jim, myself, or Carl about the AME, anything that you heard so far today, any interaction will be welcome. So if anyone has any questions. No? Oh, there we go. Oh, how to engage with the AME, where to start from. And that's a bit of a loaded question. It's from an ex-staff member who now is working for a local OEM. So I think that the way to engage with the AME, as you see today, there is technical teams across 7 disciplines based in this building. Those disciplines will cover the more traditional material sciences, structural integrity, manufacturing metrology, functional materials and chemistry, but also we'll cut across to sustainable manufacturing, digital manufacturing engineering, and innovation and technology management. So if you have any problems or any challenges that align to one of those teams, what we would do is introduce you to the team leads. Both myself as the AME director and the team lead would go and talk to you as a potential collaborator and try to identify what your challenges are and how can we help you. And that help might be in the form of a student project. You know, we have around 90 projects every semester for our students upstairs. So we are always in need of new ideas for projects, and we like a variety of projects. So it might be just a student project that you have for a few weeks or a couple of months, or it might be a knowledge transfer partnership. We do loads of those as well, where the Innovate UK will subsidize a postdoc in working with your business to actually help you fix a challenge. And that gives the university some funding to actually put an academic to coach that person in your business, or it might be a larger project. So you hear today from people in the APC TDAP program, that's the Technology Developer Technology Development Acceleration Program. So there are small companies on the TDAP that we work with and we help by providing access to labs and resources here. If you are a larger partner and have a bigger idea, then probably we'll go for a larger amount of funding that will help both you and the university. So there are many ways to work together. I think the key is to start the dialogue, start the conversation. So today is about, partially that. So if you are here, you see anything that you like, any ideas that you have that you want to talk to us about. The AME is unique in the way that we do the teaching here and the research, but we also have another translational institutes across Coventry University, and I'm looking at some colleagues here from the research organization. So Rohit and Simon from our low carbon center. They have a center similar to the AME. It's called CALPS. It's the Center for Advanced Low Carbon Propulsion Systems. Hopefully I got it right. So they are here on site. So if there is anything fundamental on propulsion systems that you're looking at developing, they have an amazing hydrogen lab. They have battery testing and manufacturing facilities there too. So we are here to talk to you. So if you have any questions, any problems, a problem shared is a problem halved. That's our philosophy. So tell us and we'll try to help. Any more questions? Yeah.
Thanks. Andy Williams from the City Council. I think this is a fantastic initiative. Been here since the beginning, championing it and really excited about the next 10 years and what that might look like. My question really, as leading on part of the West Midlands Gigafactory that we're trying to secure in Coventry, how can we leverage this asset to secure the Gigafactory?
It's a great question. I will try to partially answer it, and I'll hand over to Carl as well, because Carl has been involved on the discussions around the Gigafactory. My opinion, and probably is not a very positive one, of the efforts for the Gigafactory, and you hear more from Ravi, who will have a lot to say about the Gigafactory later as well, one of the startups that we are supporting, is that we need to consider the wider supply chain and the wider skills required to actually have, just having a Gigafactory that is not competitive on a cost basis is not going to do us any good. We're going to just sink a lot of money in, and local OEMs will still procure it from overseas plants. We heard, I think last week was on the news, a new cattle battery factory in Poland producing a cell every second. That's the sort of competitive environment that they have. Now, where I think we could be very competitive is if we look at the whole chain. And what I mean by that is looking at how we design the products, how do we integrate the cells into the modules, and how we integrate the modules into the pack, which is the great work that Unipart does next door. But also, how do we then take the spent batteries and the reused batteries and put them back into other battery packs and into static energy storage? And in the worst case scenario, how do we recycle them back into black mass and into, we have a great research team in Coventry working on bioleaching, which is using biological, consortia to actually recover some of the rare materials and reuse them in the supply chain of batteries again. So I think my view on that is that we need to think of the wider supply chain, think of the wider skill set that we need. What is critical to achieve this kind of integrated and competitive supply chain is engineers that actually understand more than just their silos. More than just the bit that I'm making today. I need to understand what my customers and suppliers need, and then how can I be more efficient as a whole rather than individually as a Gigafactory. Carl, would you like to say a few words about it?
Yeah, thanks, Marcus. You've answered a lot of the question, I think, already, but fundamentally, I think a university in a region's got a role to play in terms of how that region develops. So both ourselves and Warwick have been very much involved with your team, Andy, in how we can make Coventry and Warwickshire an attractive region for an investor to come and set their Gigafactory up here in the first place. And it involves lots of different things in terms of the infrastructure in the region. But one of the things we can offer up is some solutions to that skills challenge, because the Gigafactory might need around 6,000 people in the Gigafactory, and then there's all the supporting businesses around it. And where do they come from? If the labour force is not there with the right skills, then it becomes less investable. So we've been working very much around the whole electrification skills piece, and actually launched earlier this year the Electric Revolution Skills Hub, which is hosted in Coventry, but it's a national initiative funded by UKRI. And what we do with that is try and connect people who want to learn with the people providing the education and the jobs to try and connect people up through that hub in electrification. Also with a body of knowledge that tries to build a community, but also demystify some of the confusion around language between business and academia and education, so that we can get the right programs to address the right skills. There's also some work going on around a national skills framework now in electrification to say what are those skills, because we don't need necessarily 6,000 electrical engineers in a battery manufacturing plant, or even 6,000 battery engineers. We need people who understand maintenance and robotics and automation. And we need the support in businesses as well. So as Marcus says, the dealing with recycling, whether it be recycling of product from the manufacturing process or from end-of-life batteries, and having a full circular economy there to make it as clean as possible, we can help in trying to create those roadmaps, develop the technology programs to support it, and then deliver the skills to all of those businesses, not just the gigafactory, but the supporting businesses as well, that they can need to make that transition. Okay, thanks.
Okay, any more questions? If anyone has a last one, I've just been told the coffee is ready now, so we can go up. Just one other thing before you go up. On the left-hand side here, there is a team of chaps with VR headsets. So if you want to experience what it's like to be on the digital model of the AME in the metaverse, feel free during the coffee now or during the lunch break to go and have a go at wearing the VR headsets and seeing the virtual environment that our international visitors are experiencing. Okay, with that said, I think we do back at 11 o'clock. So go and enjoy your coffee. Thank you. Welcome back, everybody. I hope you enjoyed the coffee and the networking. I got to catch up with a few people I haven't seen in a while. It was really good. We will continue now with the stakeholder perspectives. This time around, we'll get into a little bit more detail on some projects and some case studies. We'll also hear from Philippa Oldham from the APC, who will give us a little bit of a perspective of a funding body that has worked alongside the AME and our partners for a while. So this is the list of people that you'll be hearing from in the next section. Just before we do that, I just wanted to recap the AME model and explain a little bit more of our three-pillar from John. What we do here in the AME is split into three areas: skills and training, research, and business growth. And they are not isolated activities. They are not silos. Although we represent them as pillars, they are completely integrated with one another. And the way we integrate them is by linking the content that we teach our students in the classroom upstairs with practical training sessions here in the shop floor that you'll be seeing today. What we are really proud of having in the shop floor in the AME is industry representative kit. So we have the more traditional manufacturing processes represented here on welding, robotics, machining, but we also have the latest, Siemens and Festo connected curriculum. We have some colleagues from Siemens here today, and we use that to teach engineers what designing, testing, simulating a product looks like today and what it's likely to look like in the next decade, so that we prepare them to actually work in research projects and help our partners accelerate their business. So it's really important to not see these as isolated activities, but see them as integrated, as a cycle, if you like. Now, how do we bring that cycle to life? Over the years, we develop a very simple 4-stage project, and I think Hyperbat is a great example of how that process works. So number one, on the top right, left-hand corner for you guys, is the first stage. There was a question, how do we engage with the AME? That's the answer to that question. The first step is to engage and start an ideation process. What we mean by that is we want to hear from you what do you think are the disrupting factors that are affecting your business. It could be skills, it could be investment, it could be a particular technology that you're interested in. What we do with that is we generate a pipeline of ideas, we generate a list of potential projects, and what we try to classify those into is medium, long-term, and short-term activities. The reason I left short-term for last is because I will talk about short-term first, and that's when number 2 comes in. So that plan phase is more than a plan, it's almost a feasibility or a pilot testing. So what we normally do as a second stage with our partners and collaborators is we look at the assets and the skills that we have in the AME. So what is the kit that I got here? What are the skill sets that our staff have? And how can I put them to your use without you having to spend money? And that's what differentiates us from other innovation centers in the manufacturing space. You probably know some big names around the Midlands. We don't need to ask the SMEs for money up front because we are trying to co-develop ideas and solutions. Some of those will lead to contract research, and we love to have those and bring income into our organization, but we also recognize that sometimes there is no business case for you as a company to actually invest a lot up front and take a high risk. So what we do in those cases is we do a very simple pilot here. It might be, using our sensors lab to develop a new sensor. It might be creating a digital model to help you test a facility. So we'll do those as a stage 2. Now, out of every 10 pilots that we do, probably 4, 5, 3, depending on the technology readiness level, will succeed. Those that succeed, normally we push them into step 3. So we call it building a minimum viable product. So if I take this back to the Hyperbat example, the roadmap that Carl described at the conception of the AME told us most of the challenges that Uniport was facing on the transition to electric vehicles. With the kit that we had here and the MTC, we were able to do a small pilot. And that small pilot informed Unipart, Williams, and some of the other partners on putting a bid together to get some funding to de-risk investment. And that's what step 3 is all about. How can we help you attract funding and de-risk investment in manufacturing and engineering? So in the case of Hyperbat, that was an APC 6 program that brought about £12 million to 6 or 7 partners, and that helped Unipart de-risk the investment in a battery facility that's next door. And that leads to step 4, which is accelerate and scale. And at that point, we just provide support, but it's over to the business, it's over to the company, hopefully to deliver some economic, social, and environmental benefits. In this case of Hyperbat, we tick all 3 boxes. It's great. That's why we're talking so much about it. So just to contextualize why we are celebrating today and why we are relaunching the AME, what you see on that diagram in yellow is where we are today. So that's the original AME. We spent about £9.5 to £10 million, partially funded by Coventry University, the lab locally, but also HEFKI. And obviously we put a lot of research investment into the equipment in that yellow building. What you'll be touring today, and you'll be seeing, is the green part on the top in there. So that used to be the development facility for Unipart, which since then moved to another building. We refurbished the entire building, and we added another 1,800 square meters of shop floor, plus a nice office upstairs to be able to consolidate all of our research teams here. But more than consolidating our equipment and our labs in the same facility, the aim of that building is to open up the AME to the wider supply chain. So what we are looking for here is to create an ecosystem where you can have low TRL, low MRL, TRL being technology readiness level, MRL being manufacturing readiness level. We want to have a range of companies with low TRL and MRL in that building where we can support them and take them to a mid to high TRL, where they can benefit not only from our support, but also from Unipart's support. So Unipart can be a manufacturing partner on site. Again, you'll hear from Andy some examples later of some projects that we've run out of the AME and how that generated economic benefit. Some of those are traditional areas in manufacturing. They're not so transformative like Hyperbat. So what we hope to do with these SMEs and startups is to fill the pipeline for Andy with another 10 technologies that he can take to market and help those 10 companies develop their tech and perhaps license it, look at different business models. So that's what we are looking at in there on the green building. So when you go for your tour, you see all of our labs. I will not describe any single one of those individually, but you have an opportunity to see and hear what's going on in each of those areas. So that's all that I wanted to do in terms of recapping the AME model and the expansion space. I will now hand over to Philippa Odom from the APC, and Philippa will be talking a little bit about the APC perspective. Thanks.
Thanks, Marcus, and thanks everyone for inviting me to be here today. So my name is Philippa Oldham. I'm Stakeholder Engagement Director at the Advanced Propulsion Centre. You've heard a number of different projects that we supported the funding for, but with this opportunity, I'm actually going to take the chance to say that the APC is actually 10 this year, and we wouldn't be 10 without the industry partners supporting us and working with us to drive it forward. But I just want to share a few of the milestones that we've achieved so far, and then delve into those in a bit more detail and how activities like the work that happens here at AME is supporting that development. So hopefully this works. Thank you. So with that, there are three sort of core messages that we try and focus on at the APC, and that is funding, expertise, and collaboration. And I think one of the key things here is to look around us and where we are. And the relationship with Unipart, Coventry University, the Advanced Manufacturing and Engineering Centre, has led to 5 collaborative research and development projects since our concept. And I'm delighted to say Unipart were involved in APC1 and the Active project. And really what that's been about is bringing consortia together. The funding that's been received by those 5 projects is around over 74 million of investment, both from industry and from government, to really look at how we transition. And the technologies have changed, as Carol touched earlier, a lot of it is around engines, and that's where a lot of innovation expertise is in the UK. But what do we do to transform our businesses and our sectors and the skills that we have towards the journey of electrification, whether that be in batteries or fuel cells or the low carbon fuels that other sectors might need? So really around that, though, it's the partners that are involved. And I know we've touched on a number of them, and I know a number of them are working here as well. But, over 28 partners. And again, with that funding, what's been, again, a real transition that we've seen over the last 10 years is traditionally there may be one OEM involved in the project, but now we see multiple OEMs working together because nobody has the answer. Everybody needs to know what the solution is and how they can work together to make sure the UK remains competitive. So next, I want to touch on the expertise. And Carl really touched on it earlier in what he said about pulling through research. What we've seen from a number of our projects where we have academic partners is that real transformation of businesses, looking at where the research can actually provide them with those game-changing solutions because they're not traditionally bound by some of the constraints that we can be when we work at large organisations, and we can really push the engineers that work with them, show them actually how they can develop their capability, develop their skills, and help develop some of their manufacturing processes, as we've seen with things like Hyperbat and Hyperchain, and really look at how we can adopt those to, again, ensure that competitiveness and drive that opportunity for those businesses going forward. And the Advanced Manufacturing and Engineering Institution really helps the transference of those skills. We heard it from some of the students in that real-world application, and that is such an opportunity for industry to work with organisations like this. I know Unipart are benefiting from it in actually how they can help train their next level of workforce. I remember about sort of 5 years ago, I think it was saying that we were going to lose around 300 or 300,000, I think it was actually, of our manufacturing engineers over the course of the next decade. And actually, how do we really look at what we can do to keep those skills or absorb the knowledge that they have and put them in either to automated systems, but transfer to the next generation. And again, facilities like this help do that. I'm also delighted that, again, institutes like this help some of the startups and the small businesses. I know Ravi from Global Nano Networks is going to be talking earlier. He's actually part of our Technology Developer Accelerator program, which, again, is looking at how we nurture and how we grow and how we support those new businesses, giving them business mentoring, giving them access to facilities to develop their product and their offerings, and really drive that forward. So again, using that expertise that they have available here to them. The next one I also want to touch on is digitalisation. I know we've heard a lot about the work with Unipart and the Hyperbat and the Hyperchain, which are all very important. But again, another great project that you'll see if you go on the tour is the Ox Delivers. So that's an APC 19, so a recent round of funding with the Clean project. So Ox Delivers is a new business, again, a sort of a new OEM that's actually building vehicles to operate in Rwanda, to go to those hard-to-reach destinations. And through working with AME, they've helped develop the digital twin capability. And actually, what is different about that business model for the Ox has is that they're developing one vehicle and then looking at how it performs and operates on the ground to then feed that back through the digital capability, through the digital twins, and feed it back into design to improve it before they build the next one. So the vehicle will constantly improve as it gets developed. And again, that's through the collaboration and working here and the expertise that it's getting here. So onto collaboration. Those 5 projects that I talked about work with 28 different partners. So again, the importance of the supply chain, which Carol touched on, you know, working up and down with the other OEMs, to tier ones, to SMEs, to universities. How do we really pull through and accelerate? Often we don't know what capability we have down the road. So actually, how do we do those introductions across different sectors, across different businesses, across different regions, to really understand, again, what the opportunity is for the collaboration? And again, engaging with hubs like this can help do that, broker some of those relationships. And that's something that we try very much to do within the APC as well. And again, it comes across, you know, you've heard it from both Marcus and from Carl about the relationship they have with CEALPS, the FEV Centre, but also the relationship that they have with the Electric Revolution Skills Hub, which is part of the Driving the Electric Revolution Challenge. You know, really important things, everybody driving in the same direction to really make the UK transformational, and that's a really important part of this entire journey. Not only that, but, you know, the APC, we like to work with other organisations and our partners. Over the 10 years, we've worked with over 480 different businesses. And it's about coming back and keeping those relationships going. A couple of weeks ago, a few of my colleagues were here with the Unipart guys looking at how they can develop the technology. What are the next projects they're going to come in for? You know, who else should they be collaborating with? Where can we go with this? And that's a really important relationship that we try and build and make sure that we as the APC are feeding back as well to government about the fact that the automotive sector is in that transition time and it still needs the support to enable that growth. Finally, I just want to touch on the skills. So those 5 projects have safeguarded or created over 4,500 jobs. And we don't say created because we recognise some of the safeguarding. And again, that comes down to the supply chain and the transference of the skills, because a lot of people would have made components and systems for the internal combustion engine, and there's a panic, you know, amongst some of those businesses about how do they transfer, where do they get the right skills. And again, chatting to people in this room, working with the different partner organisations, you can look at how you can transform your business to fit within the new model and the new electrification piece. And I think the key thing here is the pace of change is going to continue to accelerate. I'm not going to touch on it very much, but the sustainability piece, people know it's a big passion of mine. And sustainability and digitalisation, again, offer the UK a real opportunity for growth. But it's opportunity for growth because it can drive down cost, it can drive down time to market, and it can improve our competitiveness. Sustainability is something that we're all challenged with electrification. We're all now challenged with sustainability and how do we get to net zero. And again, the only way that we're going to do that, and the real opportunity the UK has, and we've seen over the last 10 years, is that drive and that ambition to continue to collaborate. And finally, you know, I just think it's, you know, I'm delighted to be here and being asked to speak as a stakeholder, because I think what's happened with the relationship with Unipart and AME and Coventry University is a real, you know, gold standard, really, because it is doing exactly what industry needs it to do. It's developing those right skills, it's helping businesses develop their capabilities, and it's a real gold standard for the UK. So thank you for inviting me to speak. Thank you.
Thanks, Philippa. That's a new stat that I didn't know. 4,500 jobs safeguarded. Well done. Great. So now we'll move on to the next stakeholder perspective, and it's my pleasure to invite Andy Davis, who is Business Development Director for Unipart Manufacturing, to join us. Andy, if you can stand in the lines.
Okay. Cheers, thanks. For those who didn't hear it, there's my name and title. I've been involved with the Institute since its first inception. I remember the very first meeting in Carol's office with John and with Steve Parker, another guy involved with the university. And I think my first impression at that first meeting was this could just be too good to be true. But we stuck with it and absolutely delighted. But when I look around the room today, I see loads of other people who stuck with it as well and made it such a success. We've got people here that helped set it up in the first place, like Dean and Andy Hind as well. And it's just great for everybody to get together and celebrate that. So please bear with us if it feels like a bit of a party for you all. It is for us too. But it's been an interesting time. I think it was one of the non-exec directors at Unipart that said to me, lots of projects end up as orphans, but this one will have many fathers. And lots of people would claim credit for the establishment of the AME and the success of the AME, but I think it is testament to the teamwork that's gone on between the university, between ourselves and other businesses, between the funding bodies like the Advanced Propulsion Centre and others, that we've got to where we've got to today. But it's not really about today, it's what happens now for the next 10 years, because as you've seen, we've got to reinvent our business. So we'll move on to that and have a look at that. First of all, I was asked to explain how the collaboration works in practice for a large company. And so I'll try and do that as simply as I can. But if anybody wants to know any more, please catch me afterwards. By the way, my view on these events is you get 3 benefits. About a third of your benefit comes from listening to the content. So hopefully you'll find this useful. A third of the benefit comes just from sitting and listening, sitting and thinking, because you can think about how things apply to your own business. So if you want to switch off, I'm okay with that. And the third area of the benefits comes from networking. It's the people you meet, it's the people you talk to. So if you want to know more about what Unipart does, and you want to talk to us about how to work with Coventry University, or how we could work together in collaboration, that's what today's really about, so please do catch us afterwards. Now, how does it work in practice? Well, that might be more readable for you than it is for me, but there's a number of things that we do that are really quite important. So we do have a supervisory board that meets quarterly, that sets the framework for the way that we work in the Institute. We also have a management board that tracks the sort of metrics every month. But actually, the real work is done in the weekly meetings and on the day-to-day collaboration. So these are separately coloured and labelled because actually we bring both our problems to the AME and we also bring our opportunities with today's customers and the things we're looking at in the future. And we also bring our existing partners. We bring our customers to collaborate. We bring our suppliers to collaborate. The university does the same thing, but they come at it from a slightly different angle. We're bringing the business angle. They're bringing often the research angle. So they'll understand what the priorities are for UK PLC 10, 20 years ahead, because that's the timescale they're working to. And they're saying the things they think it's important to be researching. So they bring those ideas, and they also bring their partnerships and the other areas they're working on in business. Recently, Carl and Marcus took time out to take myself and Carol and tour the technology park, another part of Coventry University, and see all the different areas of business. And that was time just taken to stimulate ideas where else we might work together. That's fantastic. But as I say, not everything goes into this hopper, but what we do is we take the ideas, we continuously learn about each other's businesses and what we're trying to achieve, and then we chew on the opportunities and see what projects we can drop out at the bottom. But not all projects are funded projects. Quite a few are, as we've heard today. But not all are funded projects. Sometimes it's just an area we need to start researching, starting to look at. And we can talk to the university about a student project or a master's project or a PhD project. Sometimes it's a problem that needs solving today. We don't go through any funnels or anything like that. We just phone up the experts in metrology or metallurgy and get the help we need. So it's much more dynamic than I can ever present on this screen. But if you want to know more, please do ask me. Carl's already talked about the strategy for the business, and yeah, ICE is paying the bills today. Electrification's probably now our short-term future, or immediate future, but we're also looking and talking to a number of different businesses now, how we can partner with them and carry out the manufacturing activities for them. It's no coincidence that whenever we have a new visit or a new customer or an important event, it starts off here in the AME. It's a little bit of an aside. We talked a lot about Hyperbat today. But our very first meeting with the team from Williams, when we talk about forming the joint venture, was upstairs in the boardroom here to talk about the opportunities to work together. We were actually talking about a collaboration on a research project that was APC6. It was brokered by the APC. Many of you will know we call them Match.com, somewhat informally, because they were the people that introduced us and we ended up married. But it's been a great partnership with Williams. But it's been great that was brokered by the APC and it started in this building. It's just a little testament to the sort of difference that those collaborations can make. I think probably to convey it better than anything else, if I'll just pick up a few case studies, so if you'll bear with me. Those who are not interested can just look at the pictures of the cars. But anyway, we had to redesign a product to make sure it could be competitive in the UK. And that's what we set out to do. We did it here, we did it in this building. It's a combination of university staff and our own employees. And that was our APC1 project, working together with Ford on Ford Active. We didn't just redesign the product. Obviously, then you've got to make sure that it will work. So there was a lot of digital testing of the parts, FE analysis. If this was live, you'd see those parts actually moving because they're simulating what will happen in real life. And then we had to do the physical testing. Again, physical testing equipment for pressure pulsation exists in this facility. That's great for us as a business because it enabled us to take that product through into production. But what's also great for is our students, because they get to understand engineering from first ideas, working with people like Graham from our engineering team, right through all the aspects of prototyping, testing, and then through into production. So it's a great experience curve for them, and obviously it's great for us too. That's in production now. You'll see some of the comments at the bottom, 26% less components, 20% less cost, and that meant we could make stuff competitive in the UK. Every single one of the fuel cells we make, about 400,000 a year, we ship, we export. None of them are used in the UK. So again, a great good news story for the UK. It talks about reduced displacement and reduced stress. I would say that's not on the project. That was reduced stress on the part. But yeah, great to win that contract. Next one, I guess, is straddling ICE and electrification because it's a PHEV fuel tank. So challenges here, probably, whereas the previous one was about partnering with the university on design for manufacture. How could they support us in that way? This one is about developing new manufacturing processes. Could the university support us in that way? So we make all of Jaguar Land Rover's fuel tanks, mainly in plastic here in Coventry. But they wanted, for this particular premium application, it needed to be in steel. That wasn't a problem for us. We also make steel fuel tanks. But the only problem we did have was if we made it from the grade of stainless steel that they wanted, and also in the way that we chose to make it, it wouldn't have contained enough fuel and wouldn't have been light enough. So we had to set about redesigning it, or our engineering teams set about redesigning it. So a lot of work done on simulation and feasibility. And then, but beyond that, there was two key things we had to do. One was develop a completely different welding process for joining the two halves of the tanks together. That's what made it fit into the space. So having made it lighter, we're now to get it to fit into the space. The other thing we had to do was to test it was durable. So to test the durability, there's a lot of test equipment exists in the facility here. We're able to make use of that. But actually, you also want to do a lot of simulation testing. And anybody who does simulation testing will know you have to correlate what you thought was going to happen with what actually happens digitally. Otherwise, you're simulating wrong results. I hope that's not too obvious for people. I had to learn that. I'm not an engineer, so I had to learn that one. And we had to do that. So how do we check it? Well, we could run the parts on a test rig here, but how do we measure how these parts are moving in practice? You won't know it, but your fuel tank pants, it expands and contracts on your vehicle, and even more so when it's running in hybrid mode. Well, there was a new technology being developed around scanning, and it wasn't really widely used in manufacturing, but we could scan a part and measure it much more quickly. I say these seats aren't normally here. At the back would be a demonstrator of this area, this facility where the sound desk is today. But it's a fantastic piece of kit where you can actually measure parts, measure them in real time. So we're using it today in production. But at that time, we were measuring the deflection of the parts and saying, what we predicted, is that what really happens? So, again, took it into production. Great business for us. And it's a contract that will run until 28, 29, 30. We're not quite sure yet, but certainly at least 28, 29, I think. And if the UK government changes its mind, maybe a bit longer than that. But it's a really exciting piece of business for us, and it proved to us that the AME could also partner with us on new technologies and developing new manufacturing processes. The third one, you've heard a lot about Hyperbat today. We refer to this one as H1 per bat, just to distinguish it from the Hyperbat, which is after many, many weeks trying to decide what we call the company. We came up with the really dramatic name of Hyperbat, which again, the APC will probably lay claim to as well. But that was our original start project. And here, we actually started this project off, and anybody who's been involved in particularly new technology will know the level of uncertainty and the amount of delay that you get is the only thing that's certain. We started this project off with Aston Martin and the PD as the vehicle. Aston Martin had difficulties at the time and they eventually canned the programme. But what we were able to do was, one, continue with the JV with Williams, which was fantastic, but also continue with a lot of the learning that we could then apply to our next project, which was with the Lotus and the Lotus Evija. A fantastic car. It will do 200 mile an hour. Continuous. It's not like it'll do 200 miles for half an hour and then drop. It'll also got a range of 200 miles, but it won't do 200 miles at 200 mile an hour. I'm fairly reliably informed. So fantastic car. How could we support that? Well, we had a number of challenges on this. And again, this is us working with Coventry University and with the AME on the application of digital manufacturing technology. Interesting to hear Marcus talking about industry before. We've almost forgot the term, because actually it's just what we do these days, particularly working closely with the AME. So when we had to look at how we could do things, we were actually facing the challenge. Normally we would put traceability and total control of quality, build it into the automation of the process. And on some of these batteries, we're making one a week. So you've not got a fully automated production line. How do you control manual processes? So there's a couple of things we do. At that time, we were running events. I won't tell you when we run them, but they're called Digital Fridays. And we used to use the space at the back of the room. And we used to demonstrate to our workforce new technologies that were coming through. It's a way of sort of sharing the learning. We used to run in here. Marcus often used to be the speaker. And we'd run at the back of the room, and we'd say, this is new technology coming through. And we did cobots. And the idea was to demystify new technology from the top floor to the shop floor. And some of the guys took the challenge of a cobot and said, how do we use this? And actually developed a machine to test our battery cells. It doesn't sound that dramatic, but actually every single cell, it comes in, they come in a box, cells, from the supplier, just like your cells you use in remote control. And all you can tell is they're from batch number X. And we have to characterise them, which means we have to test the voltage and resistance and then record that for every part. So by using a cobot and then linking that into our manufacturing control systems, total traceability, no fault forward, we could actually make sure, first of all, no bad cells were ever used. And secondly, we knew the characteristics of every single cell we used on every one of those products. And we've got 6,000 cells in a Lotus. So that's quite a lot of data that we're capturing, and we do all that digitally. First started here, our engineers working together with Coventry University and the AME. Second one, and again, you'll see this when you go outside, light-guided assembly. Fantastic for us, because Marcus and his team are now working on the next generation of light-guided assembly. We're using the current generation in production, and if we were touring the batteries facility today, you'll see us using it. What that means is, when you pick up a part up and put it in the wrong place, the system tells you, and it won't allow you to tighten the bolts up until you fix it. And that's a fantastic way of error-proofing something without having a fully automated production line. So that's an application of digital technologies for, in this case, for relatively low volume, but it's a way of safeguarding our product for our customers, and that's what's so important for us. So there's just, obviously we're doing some laser welding development. Carl's touched on that already. There are lots of other things we did, but there's just two examples. So can the AME be a good partner for digital technologies? Absolutely it can. Final one I'll touch on is Hyperchain. That's looking at how we resolve some of the challenges of scale up, really. So again, an APC funded project. I can't share with you the details of the customer because of confidentiality. And actually the team won't let me share too much about the project because we've got our celebration event with the APC next week and we don't want to steal their thunder. But just a few things to touch on. Carol talked about the laser welding and the challenges we've had there. You see, my favourite parts of this institute is the metallurgy lab and the materials labs, because that's where we work together to solve some of those technical problems. We've got some fantastic people in the business on laser welding, but we just blend that with what exists at the university. It's been fantastic for us. But there are other challenges, and probably the biggest challenge, as I mentioned before, is the amount of change that we have, late change that we have on electrified products. We always thought change was late, but you've seen nothing till you've worked on electrification. And that world's not going to change for some time because it's all new. People are learning on the fly and as they go. So what you need to be able to do is to adapt to that change. So we have to reflect the impact on our digital twin of production and say, what's the impact for us? Can we cope with it? So does our supply base. We have to share, when a customer says, can we make this change? Or when a supplier says, we've got to make this change, we can flow that information up through the portals we've developed through this project, and we can flow that information up and down the value chain and respond very quickly. So change will happen. What we've learned is how to cope with it. So in terms of growth and sustainability, is Coventry University a good partner for us, but has been so far? We've now gone on, from a Unipart manufacturing point of view, because we're looking at working with other businesses and other sectors and try to sort of solidify the areas where we think we specialise and where we're good at. Hopefully you can set, these are them, 6 things: safety critical process, complex assemblies, welding and joining, design for manufacture, supply chain management, and complex customer challenges. Hopefully you can see from just some of the things I've took you through today that every one of those we're backed up by the AME. That probably tells you how intertwined we are. I can't tell you exactly where we're going to grow in the future. Just to reassure Darren, who's our CEO, we have got some ideas. We think we know where we're going to go, but it's not for today. That's not what today's about. But what I can tell you is wherever we're looking to grow, Coventry University and the AME are with the side of us, because it's so, the partnership is so important, because we're so intertwined together. You know, these guys will know our corporate plan. They'll know what our strategy is as a business, and we'll know theirs, because that's the way that we work. We meet together regularly, and that contact's so important. So from my point of view, if you ask me, would I recommend working as a large company with the AME? Absolutely. Thank you.
Thanks, Andy. Okay, just to continue then, now we want to give you the opposite end of that supply chain. We want to give you a perspective from a startup, a small company, not small in terms of importance, but in terms of size at the moment. So I would like to invite Ravi Dashwani, is the CEO of Global Nano Network, to talk a little bit about what Global Nano is doing.
Thank you.
Thank you. If you can stick with me.
Here? Okay. So firstly, thank you everyone for giving me the opportunity to be here. Unfortunately, I'm not a graduate from AME. I wish I was after hearing and listening to everything here. But what I'm hoping to do over the next couple of minutes is just explain to you the perspective from a startup's point of view, and really talk about the value of collaboration, trust, and building that ecosystem, and what it means for us as a company to be a part of this. So we are a battery company. We are looking at both chemistry and engineering innovation. And in essence, what we do is we make components that go inside the cells that then get sold to either a cell manufacturer or a pack producer that then gets delivered to a customer for various applications. So for us, we're looking at how do we constantly improve the unit economics, how do we improve the performance across this very, very small thing that's a battery that's really driving this electric revolution and the transition in net zero. The battery industry is exactly the same like every other industry. It has its problems and it has its challenges. And you know, with different organizations like the APC and working with industry like Unipart, you develop these roadmaps to look at how you transition. From a GNN point of view, we've looked at these problems and we tried to summarize these across 3 areas. So the first we've looked at is the access to be able to deliver high power. If we think about the transition to net zero, as we electrify mining, as we electrify transportation, we are going to have a tremendous amount of requirement for high power capabilities. But accessing these today is not really that cost effective. The second is the actual production of the battery cells themselves is a toxic process, both from a mining point of view. Until that fleet is completely electrified, you're using diesel-generated engines to be able to go and extract those minerals. And then during the manufacturing process itself, you're using toxic solvents to get things to work. So in the electrode production process, there's a material called NMP that's used. You then need to go and recover this, process it, recycle it, and that's a challenge in itself. And then the other challenge we have is how do we improve the useful life of these cells? When you think about an ICE vehicle, you think about the longevity of that car. You know, my father-in-law still drives a Mercedes that he bought way back in the day. And we talk about the total cost of ownership of electric cars. You need the ability to extend the useful life of these cells. Figure out what we're going to do at their end of life as well. So the supply chain or the value chain within the battery ecosystem is really, really vast. And in order to be able to transition and succeed, we are going to require innovation at every single stage of that value chain. And where we fit in and where we play a role is in developing those new components and then working downstream with battery cell manufacturers, with end users, to be able to see how we can drive that change. So I'm not sure how many of you really know what goes inside the actual batteries themselves, and I have no interest. I'm not a PhD in electrochemistry either, but I thought I would just take a moment to explain how, from a startup's point of view, we think about this. So in a battery cell, these are the core components that you have, the thing that we look at, which is the outside enclosure in the cell. As Andy and Carol have mentioned from a Unipart point of view in their experience, it is really difficult to get things to weld together, right? And any mistakes there is going to cause this battery to leak. As we go down that chain, you look at the bottom, you have these electrodes, the cathode in a battery. It's the positive element. And as you can see, this is a representation of the overall cost of production for a cell. So the cathode does represent a significant cost. Now, part of that is due to what I mentioned before, the use of these toxic materials and the manufacturing process. So obviously, being a business guy, I said, what's the most expensive component? Why don't we start there, right? That seems like a clever place to go. So as a startup, we then matched this back to the team and we said, what are the skills that we have within the business and what can we do? But what I want to explain over the next couple of minutes now is the challenge that we have as a business, as a startup company, and what we need to think about and what we need to do. So you figure out the component you want to innovate on. You then say, great, let's go raise some money. You then have to figure out, what do you want to do? What are you focused on as a company? Are you focused on making the industry more sustainable? Because we all know that sustainability comes at a cost. Is the customer ready and prepared to pay for that cost? Is that what we're trying to drive? Are we looking at improving the performance of cells? If we want pair-to-power density, who's going to pay for it? Where is the business case? Once you come up with some sort of roadmap and plan for your own company, which is what we did at GNN, you then need to do another exercise. And then you need to start thinking, great, can we do this at scale? Can we do this at the right cost? And can we then deliver that performance? And by the way, we don't have the answer. We're trying to do all of this at the same time as raising finance, as working with industry. And so the answer here is the only way to do this is through collaboration. And that's why AME has been incredibly useful for us. And being here on the Unipart site has been incredibly powerful for us to be able to go and create that collaboration that we need, giving us access to industry, understanding the challenges, because we share very, very similar problems, just at a very different scale. So what do we do at GNN? What have we developed? I'll stand this way because it might be easier to read that way. We have developed a high power current collector. So this is the piece that is the component within a battery cell that the cathode is built on, so the substrate. In most instances, it's made of aluminum. It's a roll of aluminum that is sold or supplied to a gigafactory that then gets all those battery materials produced on top. So where's the innovation in what we do? What we do is we have developed a proprietary coating which acts as an interface between the foil and the battery material to improve the performance of those cells. Moreover, you can't just have a coating without actually knowing how to apply it or use it. So what we've then gone and done is developed a proprietary roll-to-roll manufacturing process to be able to go and produce this component so that it is relevant and usable in the industry. Working with the AME in collaboration with them, we're now looking at how do we use simulation and digital twinning to be able to help us with automation, understanding our processes, and be able to improve our route to market and actually accelerate that and bring it forward. And as a technology, I mentioned NMP. What current collectors gives us an opportunity to do is shift towards a dry manufacturing process. So this is where we would be able to produce electrodes or battery cathodes without needing this toxic material. So what does it mean for the industry and why is it relevant? As an example, in a battery pack that's about 74 kilowatt hours, you require approximately 3 kilos worth of this material. And it represents about 6.5% in terms of cost in those individual cells. When you have hyperfoil or the material in your battery cell, you're going to be able to charge and discharge your cells that much quicker, 2 to 4x. What does it cost? So based on some activity and work we've been doing with the AME and pulling our financials together and understanding how we scale up, and with the support of the APC, we've been able to identify that it's going to cost cell manufacturers approximately 15 to 25 pounds per kilowatt hour to be able to access this technology. So what does it look like in terms of a value chain for us? We will license our technology to foil producers, and we will market our technology to cell manufacturers and downstream to our end users. This is just a representation, and you'll see some companies and organizations, many of them you're going to recognize, but I want to draw your attention to the value chain, right? And it's a UK-based value chain we're working with. Bridgenorth Aluminium is the UK's only aluminium producer and potentially the only opportunity we have to really build and bring manufacturing here for this critical battery component. We're currently working with them. And we're also working with WAE to be able to go and demonstrate what our technology can do for their specific applications and helping them with those high power capability needs. So now I'm going to take a moment to just really quickly explain the challenge for us as a business and the challenge for the entire battery industry as you try to scale up a new startup or a new technology. Every business in the battery industry will go through this similar journey. And what you end up having to do is starting off really small scale. So you prove this thing at small scale, and I'm sure for Unipart it's no different when you're talking about building prototypes. With us, once you then go and scale up into a slightly larger module, you then validate your technology there. But then you have to go back to the drawing board and make sure you're not infringing on anybody's patent. And as a startup, we don't have the balance sheet of some of these larger players to be able to withstand that. And so we need to be collaborating with them and making sure that they're going to back us and they're going to support us through this journey. You then need to go and demonstrate it in a commercially viable solution. And all in all, while you're going through this process to be able to prove this to the industry, you have your own technology roadmap playing in the background. And this is what it looks like for us at GNN, right? So we started off small. We're now working with 2 different cell manufacturers to demonstrate and prove our technology and our component. In parallel, we're working with the AME, who's helping us to build up our manufacturing capability and get us ready for us to be able to supply the market. And the end goal really is about being able to produce a roll of this material. Because most organizations or most gigafactories, they don't care what we're doing in the background. What they ask us is, how much can you produce? How quickly can you produce it? And this is where, for us as a business, we can take a 10-year view on where we think we're going to be. But unfortunately, we don't have the luxury to do that. So we need to do all of this within the next 18 to 24 months and bring it forward by leveraging the digital twinning, by leveraging the know-how and the experience that we have with all the people in the room in front of us. So really quickly in terms of what we are going to be doing with the AME in terms of a project, we're currently working with them to take our manufacturing to then simulate what this would look like and hopefully accelerate and take the data and learn, so using different sensors to be able to place this onto our equipment. But this is going to help as we go down the path of understanding failure points. This is going to help us when we start supplying product to our customers and we have this traceability and accountability. From a sustainability point of view, we're also very interested in understanding the carbon footprint. And this is a big part of the work we're looking to do with Marcus and his team, is how do we go and build this into our manufacturing today? We talked about resilience and resilience for the economy, right? One of the things that we're going to be able to do to survive as a nation here is if we start thinking about the value add we're giving beyond a commodity price. And that's the only way we look at it at GNN. And this is really a big part of that collaboration with the AME. And I will say, and it's conversations I've had with Andy multiple times, it's not just about what the AME can deliver, it's this entire site that we're built on. We are incredibly grateful to have been given the opportunity to be here and physically located here and in an open plan environment to collaborate. And we see that the value that they've talked about today specifically is all the things that we are going to face as we go through this journey. And being able to have collaboration across the entire ecosystem is even more powerful than just working with one partner. And so where we see our plans next is we look at the capability and the skills that we have here. We look at the access to infrastructure and materials that we don't need to procure ourselves anymore. For example, with metrology, we don't need to go and buy 2-3 million pounds worth of kit. We can collaborate with the AME to actually get access to this and demonstrate what we really care about. What we see now is that there's an opportunity here to be able to work on this site and potentially bring pilot production capability to build those battery cells. This is how we accelerate our development and what is needed for our business to succeed. And so in conversations, we're looking at what we can do to really bring this forward and actually demonstrate and bring those skills that can then be leveraged not only for core GNN activity in our roadmap, but for any projects that the AME is working on, any projects that Unipart's working on, and the entire ecosystem of customers that we're involved with. So for me, this is a really, really incredible moment, because when I think back at when we started back in 2018, we had an idea. We came together as a team. My colleagues are sitting here in the background. They have relocated to the UK from many, many different parts, some really beautiful places around the world. And they have come here on this firm belief that we will be able to help this transition and be a part of it and create value in something really new. And today where we are is, in the last year alone, we've been fortunate to have been funded by UKRI on a couple of different projects, working with Williams and a few other players. We're now working with the APC on the TDAP program, and most recently, we've just established our innovation lab here at the AME. So really grateful to be here. So with that, I just want to say thank you. Thank you to everybody, Carol, Andy, for having us on the Unipart side, and all of you, and Carl and Marcus for inviting us to be a part of this, and also, of course, Philippa from the APC and your team at the APC for helping us get that funding we needed to be able to be a part of this. So yeah, we're here. If you'd like to speak, we're all wearing branded gear, but please come and say hi, and we'd be happy to share more. Thank you.
Okay, thanks, Ravi. We are, just to let everybody know, we are running behind, is the result of our delayed coffee. So I think we're looking at starting the tours 20 minutes late, which will affect the lunch time. 25? 15, there we go. We'll get there eventually. So don't worry, lunch is upstairs. We'll get there eventually. I would like to introduce you now to a different perspective, and it's Professor Paul Noon, who is our Pro Vice Chancellor for Enterprise and Innovation at Coventry.
Thank you, Marcos, and there's a very good chance that I'll be able to catch up some time for us. I guess what I wanted to do was talk about the piece of activity of the university that I have responsibility for, knowledge exchange. So teaching and research and knowledge exchange is less publicised, but I think really important and really exciting. And this place here that we're stood in is a real catalyst for that activity. A university doesn't just acquire knowledge, it has to develop that knowledge, it has to disseminate that knowledge, and it has to make it applicable to the challenges that we have as an economy and as a society. And that's really at the heart of what this university does, working in partnership to understand the challenges, to gain the knowledge, to challenge that knowledge and push, and then to disseminate it, whether that's through our students or through institutes like this, or working directly with partners to make sure that products are developed or new ways of working. And this place is really the beacon of that activity. I was recently, well, a couple of years ago, I was at a meeting with other universities from around the globe, from the US, from Europe, and they were talking about how they engage industry with their institutes, with their various universities. And they talked for about half an hour about bringing bits of factory into their institutions and students working on it. And I was sat there, I didn't know what was going on really, and I said, have any of you seen AME? And they said, of course, that's the gold standard. We couldn't even dream of getting to that standard. And these were big, really big institutions. This is the gold standard of that translatory activity that works with industry. It's not just industry coming in, it's us going out, it's the knowledge coming in and the knowledge going out and becoming real. So we're incredibly proud of what happens in this place. We're incredibly proud of the partners that we have. Of course, Unipart, but all of the other companies that work with us every day, that take our students, that give them a place to work and to try things out, that bring their problems to us. You know, I often say, thank you for bringing your problems. We need lots of them, and we need them to be real. Our students don't work on simulated issues, problems, they work on real issues that make a difference to that business. And that's a really special thing that we do here. So we're very proud of what happens. We want this place to grow. The expansion of AME gives it new life, new opportunities, new technologies. And we know that our companies, our partners, will work with us to make it a continued success. And I guess before I step down, what I perhaps would like to say is, why isn't there 10 of these in the world? There is only one. There is only one that works at this level, and I think that's down to Unipart. Really making it happen, sticking with it. It's never easy to do these things. The university and Unipart working together over a long period of time, sorting out the problems, and you know, lots of people come, oh, we'd love something like this, but you've got to do it, and Unipart have stuck with it. And so we're enormously grateful for that partnership that's endured and that has challenged and grown. And I know that it will continue in the future. But everyone else is welcome to join that journey as well, bring new opportunities, and we look forward to working with you in the future. Thank you.
Right, okay, well, I'm very, very conscious that I'm now standing between you and the more interesting part of today, which is the tours and lunch. So I will try and be as quick as Paul is so we can get back on schedule. So my job is, I think, the best job to have in a university, and that is looking after research, because you know, it is so incredible having the opportunity to work with talented individuals that are developing the next generation of technologies. And the way we do things at Coventry is extremely interesting and relatively unique and very different. And I say that based on sort of 37 years working as an educator, being educated and doing research at a number of different institutions, including 25 years at Imperial College in London, and then followed by 8 years working at Warwick Manufacturing Group as part of the High Value Manufacturing Catapult. So to me, AME is a passion of mine. It's about manufacturing and materials. That was what I've spent most of my time doing until I came here. And you know, we use this. You know, I think you know, what happens here is synonymous with how we do research at the university. And I've only got a couple of slides. And I'll try and keep my professorial 5 minutes to 5 minutes. But we have a very interesting way of approaching research. First of all, what are our objectives in doing research? The main one is having excellent research, so rigorously performed research that has significance and novelty at its heart, but also one that is going to generate real-world change, that's going to have impact into society and industry. The other part of that is making sure that the research that we do within the university touches our education provision as well. And you've seen today how that link between research, industry and education works so well. And again, this is why AME is such a great example of this. And then we enable that through high-performing teams, something that is actually at the heart of what AME does. It's around our postgraduate students, and we've not talked much about our postgraduate students today, but as well as all of the undergraduates that get trained through this, we have a number of research students as well, studying for their doctorates that come through this, and again, providing those research skills back into industry to enable that to happen. The place We have a fantastic facility of world-leading facilities that the staff and student can then use to be innovative, to create new solutions, to work with industry and solve real-world problems. So again, a great example there. And then finally, partnership. At the heart of everything we do, it is about partnership, and we've heard all about that today. I'm really just doing a summary, I think, of what's happened so far. And I'm just going to talk about this one slide. I've got another one, but I think it's a bit dull. This is where it's all about. At the heart of what we do at the university is around our research centres. We have 18 research centres now at the university, all focusing on different challenges. Working alongside that, we've been developing what we call these translational research centres, and AME is an example of a translational research centre. It's also the first translational research centre, so it's the model on which everything else then follows. And we're gradually growing them. We've got 4 more that work around the transport and automotive sector, working with companies such as FEV, with Myra, with Hariba Myra, I should say, with Motability, for example. We've got another one that works around with the local hospital around healthcare, and we're about to launch another one in the new year, which will be more around protective security. So these are becoming the AME was the first, but it's the sort of blueprint on which everything else is then growing. So AME is one of our translational research centres, and that's aligned with our manufacturing and materials research centre. So we've got that sort of collaboration that takes place. The beauty of it, and this is something that and Paul touched upon this, very few universities can really genuinely say they're working at elbow with industry, that they're knocking together in the same space. And whilst, the catapults do a lot of that, this is unique in the fact that actually the academe is actually sitting in the industrial setting, not the other way round. So whichever way round you look at it, we are actually here as opposed to industry having to make that sort of migration into academe. We solve some of the global challenges. I think the global challenges that we're trying to solve within this centre fit very much around that sustainability and clean growth agenda, which Carl champions within the university. We do that co-creation. This is, again, something that's really important. A lot of universities, they go off, they have their blue sky ideas, they develop it, they spend 3 or 4 years working on a particular problem, and then they look and say, how can we exploit this? Then they go and have the conversations with industry. And I know from bitter experience, you can spend 3 years doing something that industry is not interested in. I remember going to Jaguar Land Rover many years ago saying, I've been doing some really interesting work on magnesium. And they go, well, we make cars out of aluminium, not magnesium. So, we're not that interested. And I was really quite upset because what we do here is it's co-creation. We're starting, I think, Marcus talked about the ideation stage, but we work together, work out what the problems are, look at what the research questions are that we can work together to do, and then we get that innovation and accelerates that uptake of that innovation. We don't that passage of time that's required to get from idea in the head into a moving vehicle is accelerated. And then, of course, what we're doing. That research has a purpose, and I think that's what is at the heart of what we do. We don't do research for research's sake. We do research that will change lives, and we talk about creating better futures at Coventry, and I think AME is really a genuine example of how Coventry can create better futures, not just for Unipart, not just for the region, but for the country and the world at large. And I will now shut up and let you go on your tours and get some lunch. But thank you very much for you being here today. Thank you.
Okay, so that's the end of the presentations. We will now go into a site tour. There will be 6 stops that are in the mapping there, 1 to 6, starting in the reception, metrology lab, laser welding, functional materials and chemistry, digital, and then projects area. Now, The way to find the group that you are located to is on the back of your badge. There will be a letter, and there will be tour guides around on the side in there. They'll be holding a very large sign with the letter corresponding your badge. So they will take you to your starting point and you will rotate. Just to let you know that after the tour, we're going straight to lunch. So we are a little bit late, about 20 minutes late, but there is no pressure. If you are going through the tour and you find something interesting and you want to talk to a member of staff, pull them to the side, have a conversation. If you are happy to be late for lunch, feel free to delay that. For the people in the metaverse, I know we are seeing only one instance in there. There is 5 instances running in parallel because we wanted to create some capacity. So we're probably not seeing everybody on that screen on the side. But for those people in the metaverse, we're going to leave you guys now. We'll end the transmission. You are welcome to continue to do a tour on the virtual world. And if you have any questions, submit them through the chat and we'll be responding to them later, perhaps in the metaverse or via email. So leave your contact details there. We'll be in touch. So that's a goodbye to the people in the metaverse. And then let's go for a walk for the people.